Good afternoon, folks. My name is Adi Hariharan, and my colleague here, Jimmy Chen, both of us will be giving you a small little introduction to Windows IoT. So before we get started, quick show of hands. How many of you have IoT solutions implemented in your organizations today? How many of you have IoT solutions in a testing phase, not fully implemented? Okay, a fair number of you. So IoT is coming, folks, right? So the way I look at it is that it is a platform that involves devices that are connected to the cloud, which provide a ton of data that allow you to do rich analytics and get a ton of insights, which is a platform to allow you to do more, like automation and AI. But then you would come back and tell me that, hey, we've had automation, right? We've had automation for decades, so what's new about IoT? But that's true. Automation that you had was confined to these high-value projects. You think about a production line. You automated it, tested it, made sure that everything worked, and then you shut it. You locked it. You locked it for another 20 years. And I think you probably took the keys to that solution and you swallowed it. You just didn't want anybody to have access to it. But that really wasn't a scalable solution. That wasn't something that you could really go and evolve. When you think about IoT, and you think about the components that go into IoT today, the cost of these components are coming down. The cost of connecting these components are also coming down. And then cloud solution being prevalent everywhere, is becoming really simple to connect these devices to themselves and to the cloud. And you see IoT being adopted across several industries. And you think about digital transformation. You guys, a lot of companies want to accelerate the digital transformation, and they want to use IoT to do that. But here's the problem, though. It is not easy. As much as IoT is trying to democratize the fact that you can run rich analytics on a lot of your infrastructure, think about it. You have legacy infrastructure that you have set it up yourselves, or you had an OEM install this equipment and this full solution within your infrastructure. So you have your own system, you have an OEM system, or you might have a combination of the two. And they simply don't talk to each other. There's a fundamental incompatibility between the different platforms, and the fundamental incompatibility between the standards and protocols that these systems just find it difficult to communicate with each other. And then Microsoft and Amazon and IBM come knocking on your door and say, hey, throw in a cloud solution, and then you will unlock some insane amount of potential. At Microsoft, we realize that. We realize that our customers are telling us that it is complex. It is not an easy thing to do. We think we have a solution for you. And the way we think about a solution is, one, we start with Azure IoT. Azure IoT is a great cloud solution, and it has a lot of packages within the offering that will help you up and going almost immediately. But then we don't stop there. We think about the device as well. We think about what technology can be integrated into the device and make sure that the integration is seamless from the device to the cloud. A couple of things. One is that we want to make sure that you're able to do some rich analytics on the cloud, but you also have some rich experiences at the device level, and then you're able to transfer workloads between the devices and the cloud. And what that will lead you to is the intelligent edge and the intelligent cloud. You may have heard Satya talk about it this morning. But this is something that we want you to be able to embrace, and we want you to be able to up and go immediately and very, very quickly. And that's our goal. So why choose Windows IoT? There are a lot of vendors out there. And a lot of them are great too. But you think about Windows IoT, we've been in the embedded business for about 25 years. We've shipped a lot of products. We've been shipping embedded products since Windows 3.1. Think about IoT. Think about the changing landscapes. You have changing standards. You have changing technologies. You have changing protocols. You have different peripherals, and also you have the drivers for those peripherals. We've managed to take all that and integrate it into the platform. We're doing a lot of the hard work so that you really don't have to do that hard work. And you think about Zogo, and then Jimmy will talk to you a little more about Zogo, that they chose Windows IoT because of the maturity of the platform. The fact that they could up and go and ship the product in a year speaks volumes about what the product can do for them and can do for you as well. So Windows IoT really helps you get to market faster, provides that end-to-end security, make sure that you have a great edge solution, and then it comes seamlessly integrated with the cloud offering. And we want to be able to help you in your IoT journey. So what does that journey look like? So as I mentioned, in your company, you could have a customized IoT solution that you have built ground up. Or you could have an ISV come in and offer a solution that could live on top of your infrastructure. Or you could have an OEM come and offer you an end-to-end solution. And in those three things, it's basically about following this four-step process of building, making sure that the things that you build are connected, and then you're able to scale that, and not just stop there, but you also have to operate and maintain it. Jimmy here will walk you through how Windows IoT helps you do that. But before that, I want you to watch a video. Quick 2-minute video. Gives you an example of the work that we've done with this customer. And it'll give you a sense of the role that we've played in it and of the role that Azure has played in this solution as well. Here you go.
Pure luxury and hospitality at its best. That's what Steigenberger Hotels and Resorts has been standing for over 80 years now. Our Steigenberger Airport Hotel in Frankfurt utilizes modern technology that not only improves the great guest experience for our business travelers and leisure guests, but attracts new customers and builds loyalty. We have a well-trained, motivated and enthusiastic team. But to get to an even higher level of service, we decided to implement a technology solution that allowed them to perform at an even greater level of productivity. Sumfix is a unique back-of-the-house software solution that helps the Steigenberger Airport Hotel and guest service teams manage their daily work. Housekeeping takes advantage of this solution on a new IoT wearable from Trackstore running on Windows 10 and Microsoft Cloud. The wearable helps create great back-of-house operations by letting our management team generate service and cleaning plans in real time. The solution can share a guest's preferences with the staff to ensure they have the great experience we are expected to deliver. We can do this and create savings from more efficient operations by taking advantage of the IoT technology and deliver to our guests the Steigenberger experience of true luxury.
So I'm really excited to be here. My day job, I work with partners like the one they just saw to actually build those IoT products. And building those products and devices is not as simple as you would expect it to be. And the many things that you actually need to think about. In the life cycle of building a device, trying to actually connect a device to Azure, trying to scale it so that it can actually have tens of thousands, hundreds of thousands, or even millions of devices. And then the question of how do you actually operate those devices. You can do that by having a Linux operating system, put it on a small device, have an IS server running in the cloud, and connect to that. And then you run into scalability problems. You run into management problems. You run into device update problems, security problems. So those are the problems that you actually have to solve in order for this device to be successful in a solution. So Microsoft, we have a stack of technologies from device to connectivity to cloud that will help you simplify this process. Okay, so building a device. For us, it says building a device is as easy as building an app. Hopefully you don't believe that. If you believe that, it's I have a bridge for you to buy in Brooklyn's. It's not quite that simple, but at least that's an aspiration that we have. The way we allow you to do that, at least make it as easy as possible, first of all, is to have the familiar tools that we use to build an app. And the familiar operating system, well, as familiar as possible, that will just work. That will have security features and management features built in. And those we'll talk about later. And natural user interactions like touch, ink, Cortana speech, they can be embedded into the product very easily. So let's talk about the tools that we have. So as you guys know, Microsoft have Visual Studio. Visual Studio makes it very easy for you to actually build an IoT device by writing the application, deploy the application onto the device automatically, and then debug directly on the device without you doing anything special like basically, it just works. There is a single dev center that allows you to get application telemetry data, crash dump data, and things like that. And if you happen to be running the IoT Enterprise SKU of Windows, then your legacy applications will also work on this device. So when you build a device, one of the things that you really often need is access to hardware. Previously, if you want to access things like I2C bus or access low-level system components, you need to build your own driver. Windows IoT makes it easy by having an embedded mode. With that, you can actually access system functionalities from within the sandbox UWP app, such as launching a process, Win32 process, changing system time, which is a privileged operation, or accessing buses directly from a user mode API, buses like I2C, GPIO, SPI buses. And also, embedded mode allows you to run background tasks continuously like a service without being subject to the project process lifecycle manager. So this basically allows you to build a device easily and access hardware easily. Of course, if you have some specialized hardware, you will still need to build drivers for, but oftentimes we find that having access to this GPIOs and SPI buses, I2C buses is a very good start. Okay, Windows 10 also continued to innovate over the last releases. One of the innovations that we had was to support additional silicons that are long life on both Intel and Qualcomm. And also, in the last release, we also supported Raspberry Pi 3. We added functionalities like device management and device provisioning, and also things like remote access of app services, Project Roam. So with those features, you can actually build interesting scenarios. Other things like power management, connected standby, where you can use Windows IoT on low-power devices. Having the thorough documentation that will guide you from starting to build a device, how to do the manufacturing, how to package things. Having the right security tools for you to enable securities like Device Guard, BitLocker, which I'll go into a little bit more about later, Secure Boot, that will basically allow you to easily enable security that you don't have to think about. Well, you do need to think about, but you don't have to worry about too much. And servicing both the application and the operating system. So Microsoft take care of those for you. So in servicing of the apps, one example would be for you to actually use the Windows Store, where you can get telemetries on your apps. You can download from Windows Store the pre-installed app form packages, put it on a device, and through Windows Store, you can service your application that's out in the wild. So imagine a case where you actually have tens of thousands of devices or millions of devices out there, and you want to update your application. Windows Store allows you to do that very easily because you don't have to build the infrastructure to do that. Microsoft already provided that. So let's take a look at Zogo video, where really it was a really good example of how they leveraged that.
We designed Zogo from the ground up to be fundamentally different than any digital signage software on the market today. It allows you to turn any Windows 10 device into a digital sign. Instead of a clunky web interface, we've designed rich native apps for Windows, Android, and iOS that allow you to control your network of signs right from your PC, tablet, or the smartphone in your pocket. First and foremost, Zogo is easy to use. Download the Player app from the Windows Store, then using the Content Manager app, scan the QR code or enter the PIN that appears on screen in order to connect your digital sign to your Zogo account. Then you just upload your media files, drag them into a playlist, and assign that playlist to one or more of your media players. You're up and running in just a few minutes. One of the most interesting things about Zogo is that it's cloud-powered. We leverage the Microsoft Azure cloud, which enables infinite numbers of media players and media files in the cloud. It also enables things like real-time mode, so you can use your tablet or smartphone to change the content that's playing on your digital signs in real time. And because our software is available in the Windows Store, all of your apps automatically update. We really love the cloud. Zogo is also customizable. We have a feature called the Zogo Playground that allows software developers to create HTML5 experiences and make them part of the Zogo playlist. In the near future, this will allow us to build apps, or channels as we call them, to display things like Facebook and Instagram feeds. In the world of digital signage, scalability is also a very important factor. Zogo allows you to manage an infinite number of signs right from your existing tablet, PC, or smartphone. In fact, Zogo is used by Microsoft to manage hundreds of interactive Surface retail locations all over the world. Now, as we mentioned, Zogo allows you to turn any Windows 10 device into a digital sign. But we're also the first company in the world to release our own digital signage player based on Windows IoT Core. This allows us to provide a premium experience to customers. There's no start menu to fumble with and no software to download. You simply plug in Zogo Mini and your digital signage is up and running in just a few minutes. Zogo is completely free to use with one screen. In order to unlock advanced features or deploy multiple digital signs, you can upgrade right inside the Content Manager app. The price is just $15 US per digital sign per month. So whether you're the bike shop on the corner or the world's biggest software company, Zogo will work for you.
All right. So that was an example of how they leveraged the servicing of through App Store for their applications. And that was a real partner that we work with. It was a real example. So let's talk about connecting. Now that we already done the building, and hopefully one of the key points that you leave from the build section was that we provide the tools needed for you to actually build a device relatively quickly. Connect. There's two kinds of connections that we need to talk about. One is connecting to the cloud, because it's where all the value add of the IoT comes from. And then there is connecting to the local devices, the legacy devices that you already have. And Windows IoT as a platform is basically a really good first-class operating system for you to connect to Azure from, because all the applications, all the APIs are already part of the operating system. You don't need to go and look for this and that package. You can just fire up Visual Studio and essentially just very quickly prototype an IoT device that connects to Azure. Connecting to Azure or connecting to any cloud is often problematic for in an IoT scenario. One of the hardest thing about it is, so you ship a device out and it boots up. So where does it connect to? Especially if you're talking about hundreds of thousands or millions of devices, where does it connect to? And we provide a solution for that called device provisioning system. So Microsoft, in the Microsoft IoT architecture, devices typically connects to IoT hub. And the problem then is, how do you know which IoT hub to connect to, right, in a secure way? So we have this IoT hub device provisioning service that also runs in the cloud. It exposes a single global endpoint. So on every device that you ship, the URL that it points to is exactly the same. And it's actually the same for everyone. So as the device boots up, the first thing after it connects to a network is to actually look in Azure, connects to a device provisioning service, and actually trying to find out where it does. The way it does that is when you manufacture a device, you would extract from the device a unique ID. And also from the device, you would extract a public key that's uniquely identifies the device. Typically, it's the endorsement key that you extract from the TPM. With both the device ID and the public EK, you will store that in a device provisioning service. Then you box up your device from the manufacturing after you test it and everything, box it up, ship it to a customer. The customer takes it out of the box, and the device boots. It talks to the DPS service. It asks, hey, I am device ABC, 1, 2, 3, what was it the other way around? 1, 2, 3, ABC. Which IoT hub should I connect to? The DPS service decides, depending on the configuration, it could be a geographically based, or it could be explicitly, or it could be round robin, depending on the associated IoT hub. It finds out which IoT hub this device should connect to. It registers the device with the IoT hub, and then returns the connection string to the IoT hub. In the IoT hub connection string, there's a symmetric key. And this is slightly problematic when you have a symmetric key in this whole thing. That's a security risk if it's not protected. So in order for this to be secure, what will happen is the DPS service will encrypt the symmetric key with the EK public key, so that only the device can actually decrypt what the symmetric key is. Then it uses that to connect to the IoT hub. Okay, so this solves the initial provisioning problem of how do I connect to IoT hub, which IoT hub to connect to. After you make the connection, typically what will happen is then IoT hub device management comes into play, and I'll talk more about device management later. So this infrastructure allows you to set up and connect basically millions of devices. Let's change the topic a bit to intelligence at the edge. So when we talk about intelligence at the edge, it's about bringing the user interactions that you expect, that users want, the natural user interactions. And also sometimes, if it's like headless device, oftentimes it's the edge compute. And to bring that, let me show you another video, a demo of what could be done on the edge.
Hello, my name's Jason Farmer with the Windows IoT team, and I'm here to talk to you today about rock, paper, scissors. I played a lot of rock, paper, scissors as a kid against my sister and won a bunch of candy, but I didn't take it as seriously as some people do. When you search the internet, you'll find rock, paper, scissors championships and tournaments all over the place. There are folks who play this thing for real, $50,000, play to get on a spot on Conan O'Brien, all kinds of championship awards, and they take this thing incredibly seriously. At the Windows IoT team, we thought about how to make rock, paper, scissors really, really good, and how to use machine learning and Azure to improve the computer's gameplay. The setup we have includes Windows 10 IoT Core and an Intel Joule. We have a camera input. We have an OpenCV classifier which recognizes the hand gestures, paper, rock, and scissors. And we have all of that hosted in a UWP. On the ML side, we have the Cognitive Toolkit running in the eval mode on the edge, and we're training our models in the cloud. We have a web dashboard that outputs the learning that's happening with our model. And every 20 games or so, we upload the game so that we can train the model better and put down a new eval system for the gameplay. What you see here is our rock, paper, scissors demo app. It's being projected straight off of that Intel Joule and Windows 10 IoT Core. You'll notice that the OpenCV classifier is able to pick out paper, rock, and scissors whenever I throw them. The other thing to keep in mind is we're not cheating. There are some things out there that can sense about when you're about to throw a rock or scissors and tries to beat you. The computer's playing completely blind, but it's often winning. So let's go ahead and play a game. Round 1, rock, paper, scissors, shoot. I went rock, and they got scissors. I won. Round 2, rock, paper, scissors, shoot. Oh, I won again. Pretty good. Round 3, rock, paper, scissors, shoot. And it's a draw. So this time I came out pretty far ahead. But as you look at our overall stats against the AI, it won 256 times. The humans only won 185 times, and we've had 123 draws. So our cognitive toolkit model is pretty good at winning rock, paper, scissors. And I'd recommend that the next time you play, have the computer sit in.
All right, so the reason why I showed that video was because it really demonstrated intelligence at the edge through the OpenCV classifier at the running on the edge device, Intel Joule box, and also the machine learning that actually runs in the cloud. So on the edge, we have APIs that allows you to do vision, speech, and sensor perception. So as an example, for access to sensors, you can have access to accelerometers, gyroscopes, proximity sensors. Those are all accessible through easy-to-use UWP APIs. And then there's things like depth perception, also through UWP APIs that already exist. Or you can use cognitive services that runs in the cloud. Things like face recognition, feature identification, object classification. You can run that in the cloud. And on the device side, all you need is a few lines of code. Computer vision, OpenCV, you saw the demo. Whether you want to run it on the device or run it in the cloud really depends on the kind of hardware that you have or the bandwidth that you have between the devices. So we gave you the options to choose like where you want to run your computation from. Speech recognition and synthesis APIs. On Windows IoT, we have the Microsoft Windows Speech Platform that does the local speech recognition. So you don't really need to be connected to do speech recognition and synthesis. Or if you prefer to have an even higher accuracy, you can use APIs that connects to Bing Cloud Speech. And lastly, Cortana and natural language processing. So as you talk to Cortana, it understands you. It uses your knowledge graph or your connections and able to act or respond to you in an even more personal manner. So those APIs are all accessible easily through UWP on Windows. So as an open platform, Windows IoT really allows you to connect to your devices locally, local hardware peripheral devices or legacy devices. We have connectivity things like USB, Wi-Fi that everyone has, Bluetooth, cellular, or you can also use industry standards like OCF or OPC UA. For other legacy protocols like BACnet, Modbus, Zigbee, you can have protocol translators that work on Windows IoT as an adapter. On the Azure side, as you build the local device and connect to Azure, we ensure that there's a secure connection, and we provide the APIs that allows you to easily connect to Azure. The connectivity that you can do with those APIs is like 10 lines of code, or even less, to connect to Azure. And then start using many of the Azure capabilities. So let's talk about scale. If you want to build more than just a handful of devices and actually ship them to customers, you really need to keep the devices secure and updated. Otherwise, it's just a problem waiting to happen. And Microsoft provides the infrastructure and the sustained engineering of the operating system for you to do that. So in addition to that, in order to scale, we also provide the telemetry data that you can access, both for your application and the operating system. To build a trusted device, there are actually many aspects of it. First, you start from the device. We could leverage Windows IoT will leverage hardware protection through TPM, which is a hardware module that securely encrypts. There's a device health attestation service that we'll talk about next that's in preview that will basically record the boot statistics and validate that the device is working and configured as expected through the boot chain. There's secure boot that validates that all the binaries that execute through boot process are signed. There's BitLocker that protects the data at rest. You can BitLocker the device just like your normal desktop Windows. And to provide resistance against future threats. And we know that bugs are found in operating systems or in services and things. So update is a really important part of a security story. Continuously update. So Windows as a service is a really good, basically, is our solution to that problem. We provide the sustained engineering service to fix any of those bugs that are found. Device Guard, where you can have you can have app whitelisting. So only applications or code signed by you can actually run. Firewall, built-in network firewalls. It's already part of Windows IoT. And of course, Defender for malware detection. In addition to that, connectivity between device and Azure is also protected. In our IoT connectivity supports protocols like AMQP, MQTT, HTTPS. They're all protected through TOS and certificates. On the cloud side, there's a variety of cloud security technologies, encryption at rest, secure device registration, like what I just showed you earlier. And then it comes to response. If the device was somehow compromised, what can you do about it? Through device management, we can basically, at scale, manage the device, trigger some remediatory actions, or potentially even wipe the device by triggering a recovery. So if we detect this device is misbehaving, we can issue a command to actually just, hey, revert to factory image or something like that, and get rid of the malware that's on the device. If all else fails, on the Azure side, we can block a specific device from connecting to Azure. So this end-to-end is there to make sure that your IoT solution is a trusted solution. So this is a new feature, so I'll go into a little bit details about this, device health attestation. So what this does is, through the boot process, one of the things that it does is it records the configurations. Like, hey, the BIOS is configured this way, have this device turned on, the COM port is turned off, the USB is turned off. It records those configurations and stores them as a boot log. And then it's signed by the TPM. And this TPM signed log is then sent to a device health attestation service that validates that. So on the server side, the Microsoft service will actually parse the log and checks that, hey, is secure boot turned on? Is BitLocker turned on? Is COM port turned off? Things like that. Then your device management solution doesn't have to be ours. Any third-party device management solution can implement additional checks, policy checks that talks to the device health attestation service that, hey, is this device configured the way it's supposed to? Were those things turned on or turned off? And take appropriate actions like the one I just showed earlier if that's not the case. Okay, so this is basically how to ensure security and how to ensure that there are remedial actions available and detect those security actions and take remedial actions when security breaches happen. Then let's talk about operating a device. So operating a device is really about managing the device. If you operate at enterprise scale, like less than 100,000 devices, there are available solutions such as Windows Intune or existing MDM solutions that can actually leverage CSPs to talk about, actually, sorry, it should be next slide. So if you operate at enterprise scale, there will be management solutions like Windows Intune or other MDM solutions that will actually use existing CSPs on Windows IoT platform to actually manage the device. But those only work at it doesn't really scale into millions of devices. So when you talk about managing millions of devices, Azure IoT have an Azure IoT device management solution. And to do that, we basically have the Azure IoT DM have several channels for you to manage the device. One is a telemetry channel, basically a device-to-cloud telemetry that can provide updates on the status of a device or anything that you want to send to cloud, and potentially for further analytics. There's a cloud-to-device message that you can send commands like reboot or go update now. And then there's a device twin where you can actually specify the properties such as the desired states. You want this device to update every Saturday at 3 p.m. Or there's a reported properties where the device will report its current state, like, hey, I'm a thermostat, my temperature has been set to 70 degrees. So with this infrastructure, you can actually manage devices at scale. So this IoT Hub device management was built for millions of devices. On top of that, the metadata that you can assign to the device twin. So you can easily query, like find all the devices that's in Florida and set the temperature to, if it's a thermometer, set the temperature to 60 degrees, just an example. So this allows you to actually manage devices at scale. And in case there is a need for direct one-on-one interaction with the device, there are commands available that are synchronous. You can just, if the device is online, you can actually, hey, reboot now. And there's a lot of existing properties that Windows IoT supports. So this was not intended to be like, hey, I guess you guys all remember the whole thing that says scroll through, right? The whole thing. So the point was not to actually ask you to look at what's there, but there's a large number of CSPs and properties that you can actually manage through the IoT management solution. So why Microsoft for IoT, for Internet of Things? We allow you to build devices easily. We provide the ability for you to connect to Azure easily. And there's a richness of Azure IoT services in the cloud that allow you to do analytics. Now, can you do all of that yourself using some other systems? Of course you can. But those things that we have is there for you to use already. I mean, things like security, management, servicing, you need to do all of that yourself if you choose another platform. So Windows IoT already provide those for you, and you can integrate those into your solution very easily. There were two SKUs of Windows IoT. There's the enterprise SKU that you can use that's allow you to access to legacy devices. And then there's the IoT Core SKU that will run on smaller devices like Raspberry Pis and devices based on Qualcomm's Dragon board and things like that. So with that, I'll pass back to Adi.
Thank you, Jimmy. So Jimmy gave you a sense of all the innovation that we're putting into the platform itself, all the legacy innovation that we've already put in the platform, and all the innovation that we're going to continue putting into the platform. And we want to give you a sense of what our customers and partners are doing with Windows IoT. It's going to be a little bit of a Netflix because I'm going to show you a couple of videos. But I'll start with FarmBeats. So FarmBeats is a Microsoft research project that is trying to reduce the overall cost of an IoT implementation for farmers in the agricultural fields. So the way they're trying to do it, I'll give you a sense of what that setup looks like. So they have sensors. They have tons of sensors in the field that's measuring temperature, humidity, and a whole bunch of things that they're measuring, all connecting to an IoT core module. And then they have drones, and they also have helium balloons with cameras that have enabled vision sensing. And then they use the unused TV spectrum to then transfer all the data to this box that runs IoT Enterprise. So this is the gateway device that does edge analytics. So it does the rich analytics at the edge, and then has the cloud at the back end to drive those insights. So I show you a short video, just give you a sense of what this team is doing with a couple of farms. And what we're trying to do on our side is try to scale that from a single farm into multi-farms, and then scale it really broadly in a commercial scale.
My name is Sean Stratman, and I'm a farmer. I've been doing this a long time, and it's clear, now more than ever, that we need to find better ways of growing to ensure a sustainable future for farming. Water scarcity and agricultural pollution are all creating pressures that farmers around the world are feeling. We are looking to human ingenuity and technology to feed our growing population.
My background is in connectivity and battery technologies, but I grew up spending summers on our family farm in India. That foundation gives me a unique perspective in my work as a principal researcher at Microsoft. New sensor technology is a great tool in providing data on soil moisture and soil nutrients to help farmers make best use of their resources. Unfortunately, these sensor solutions can cost thousands of dollars per sensor and require many sensors to monitor a field properly. Drones and other imaging technologies can provide very useful data and allow for precise monitoring of land over time. But these devices require a high bandwidth wireless connection from the middle of the farm. To solve our connectivity problem, we utilize the unused channels for TV broadcasts, which are abundant in rural areas. This allows us to transfer large amounts of data from cameras and sensors in these remote areas to a local processor at the farm and out to the Microsoft cloud.
So I send this up, and it's taking pictures all the time.
Our big breakthrough was the integration of machine learning into the processing of imaging and ground sensor data. Through this process, the data insights are magnified. From 2 finite data points, we are able to create a detailed heat map of the farm. The farmer is able to access this map and utilize it to inform resource management and to track the effects of the inputs.
Having a greater understanding of soil conditions and how our actions affect them, it allows us to put the work in where it's needed. It's changing the way that we work with the land, and it's changing the way the land works for us.
Jimmy talked to you a little bit about Zogo, and the video showed this little plug-and-play Zogo device. But what the video did not show is the ability for them to scale from a little IoT core device to a larger IoT enterprise device, keeping the investments that they made at the device at the cloud level exactly the same. So with the little IoT core device, you're able to easily connect to a single screen. It's free to use. And if you want to do a multi-screen digital signage solution, get the IoT enterprise box, plug it, and you're good to go. And then they've got this at the Microsoft Store, several Microsoft Store locations to show customers, show a lot of dynamic content based on their usage of the Surface device at the Microsoft Store. This is another fantastic solution. I really wish I had this table. Actually, the table would be there if you go to the IoT Expo. This Kodisoft table, it's yay big, runs a full graphic user interface. So this is a restaurant table that allows multiple people to use and interact with it, can allow for like 1,000 simultaneous touch. And here's how it works. So the graphical user interface on top is run by IoT Enterprise, and the touch is managed by IoT Core. So it basically uses two operating systems running in tandem. And now you'd ask, like, where does Azure fit into the whole thing? So what they use is that they use Azure machine learning in the background to basically look at the user interactivity with the menu, and they're able to change the menu real time, has resulted in about like 30% increase in revenue for one of their customers. Again, great story, how they're using both Windows at the device and Azure at the edge to see some real impact. Another really good innovation. So this is from this company called Innovi. So what Innovi did was that they used to have an Android solution, they still do, but then they came to us, and then we showed them the power of Windows IoT and told them about all the peripheral support that we have for a POS solution. So what they did was that they got this device up and going in less than 10 months. So what this device is, it's a little handheld device. It's probably about the weight of my phone here, and it has a full barcode scanner. It has a card reader, fingerprint reader. I mean, this is one of those devices that you can be successful on the shop floor, just like you would with having like a full-fledged POS device to manage the customer interactions. And again, great solution. And then they use Azure in the back end for their order and pay solution that they have. And the last one is Rockwell. So Rockwell has a solution called Shelby. So Shelby is pretty much like an aftermarket solution. The aftermarket solution they enable with this little box that runs IoT Enterprise as an aftermarket product that you can put it into your infrastructure, immediately start gathering a whole bunch of data and run some insights on Azure IoT and leveraging the Microsoft bot framework. So I'll run a quick video to show how Rockwell's leveraging Shelby for one of their customers.
We wanted to make it really easy for our customers to get meaning out of their data.
A lot of industries have data, but they haven't been actually able to make the data work for them.
Any producer is competing against great competitors from around the world, so they constantly need to innovate to do more with less.
Shelby is FactoryTalk Analytics for devices.
Shelby actually allows us to put a data scientist in a box.
It is an information appliance that our customers can deploy in their manufacturing operation to analyze the data that's coming out of the device.
We use Microsoft Cognitive Services to train the bot. This also uses machine learning. We're pushing up every event that Shelby sees and doing summary calculations in Power BI.
Great Lakes Brewery was one of our first beta customers.
We were able to help them by finding out how their assets were performing, how healthy they were, and allowing them to do it in as easy a fashion as possible.
Implementing Shelby was super easy. It took about 3 minutes, a couple of mouse clicks, and we were analyzing problems that we were then able to solve immediately. Technology allows our brewers and other process individuals to stay focused on the craft of the product rather than the process.
Most of our customers don't know that they need Shelby until they get Shelby. One of the things that we've been experimenting with is attaching the bot to a voice interface like Microsoft's Cortana.
There are 2 drives that need maintenance.
So a customer can find out the status of their system no matter where they are without taking their hands off their work. When we show our customers, jaws drop. People are astounded by the bot.
Being able to use the Microsoft Bot framework to make our product as easy to use as possible has just been amazing. It is an infrastructure that we can use immediately. We don't have to set up our own cloud computing infrastructure. Azure does all that for us. We can put our own industry knowledge on top of it and make our customers more productive.
Our customers are seeing a new Rockwell. New innovation with Microsoft is showing them that we are evolving to create positive outcomes for their businesses.
All of the devices are online, and there are 3 that need maintenance.
So the natural question is, why should you care? Why should enterprise IT really care? What you're going to see over a period of time is you're going to see this proliferation of devices within your infrastructure. It's not just going to be about PCs, tablets, and phones that you'll need to manage. You'll need to start managing a variety of devices that just unlock that insane potential that we talked about in a bit. And then we just want you to be successful. I mean, so what we're trying to do in Microsoft is that we're trying to give you the tools. We're trying to tell you, show you what's possible. We're trying to work with partners to build solutions so that you're able to leverage a lot of those solutions to try to do things to improve. One is create new business models, or increase your cost savings. We have a ton of resources, and we hope that you'll be able to use some of our resources. So we have a brand new website. You can take a look at it. We also have tons of samples and documents that you can go up and going on this website called Windows on Devices. And we also have an IoT lab. So if you want to prototype a solution very quickly, reach out to us, and then we can nominate you for some time in our lab as well. And the last thing, Windows IoT Core is free for you to use. You can just go download it and get up and going. There's, again, as I mentioned, there's tons of documentation for you to get started. A Raspberry Pi device costs about $50. IoT Core being free, it's a world of possibilities for you. And then we have a whole bunch of other sessions about IoT as well. So I'm hoping that you have an opportunity to go and listen to what my colleagues on the Azure IoT side have to say about the investments that they're making on the cloud side of things. And finally, we also have an expo area. I'm hoping that you'd have an opportunity to go there and take a look at some of the investments that we put, not only in the technology, but also some of the investments our partners have put in to make sure that we can bring some of those solutions to life. So with that, I'll close. So I'll have Jimmy up here on the stage with me. And if you guys have any questions, feel free to use the mic, or you can come up to us also. But thank you. Thank you for your time.